In our last video, we've covered how data engineering came into existence. To quickly recap, we discovered the problem that data engineers need to solve, which was the need to separate the two workloads, transactional queries and analytical queries. This need arose because businesses shifted from just recording history to trying to predict the future. We've established that data engineering is about setting up an automated system that moves data from row-oriented to column-oriented to optimize data analytics and leave operational database unaffected. But have you ever wondered how this problem was tackled before data engineering came into the picture? Did we not have this problem prior to that? Or has this problem always existed, but we had a workaround solution for it? Picture this. Before the year 2000s, before the internet, how did a business decide what to sell you? How did they decide what to stock for inventories? Well, it was simple. They guessed it based on intuition and experience. A group of executives sat in a room and argued, and usually the person with the highest pay won the argument. Sure, they had spreadsheets, but that could only tell them what they sold last year. But using historical sales data only to make marketing decisions is like driving while looking only in the rearview mirror. The data might tell you, we sold 1 million blue shirts last year, but it doesn't tell you, would we have sold 2 million if they were red? So it's not that businesses didn't have this problem before. There has always been a need for making prediction. The pivotal moment wasn't the idea of prediction, but rather the sudden ability to do it at a massive scale and the realization that the business's survival depended on it. This shift was driven by a few key factors that collided around the late 1990s and early 2000s. Before the internet, a store only knew what you bought. Once businesses moved online, they could see what you looked at, how long you hovered over buttons, and what you removed from your cart. Imagine a shopkeeper in the 1980s. They know you bought a loaf of bread because they have a receipt. But do they know you stared at the chocolate cake for 3 seconds, reached for it, and then put it back because of the price? In the physical world, that hesitation goes unnoticed and is lost forever. But on the web, this data is tracked and becomes invaluable data insight. Early websites didn't just record sales. They used JavaScript code running on the user's browser to actively monitor the user's actions and report them back to the business. For example, if the user hovered the Add to Cart button for 3 seconds but didn't click, the business knows you were interested but hesitant. They could even track when the user removed an item, indicating that the user was interested, considered it, added it to the cart, but ended up rejecting it. This provides very different data insight than never adding it at all. The JavaScript code running on the browser can even monitor exactly which part of the web page is currently visible on the screen. For example, if the user scrolls down to a specific pair of shoes and stops for 5 seconds, the site records that those shoes were in view. Research shows a strong correlation between where people look and where they rest their mouse cursor. Therefore, this data is extremely valuable to the business. So, as you can see, suddenly the volume of data exploded, offering a much richer picture of human behavior than just sales receipts. In the 80s, storing a gigabyte of data cost hundreds of thousands of dollars. By the 2000s, it cost pennies. Suddenly, keeping everything just in case became financially possible. Companies like Amazon and Netflix then proved that using data to recommend products was more profitable than just having a good inventory. This idea came from trying to solve a physical problem that physical stores had, which was limited shelf space. Amazon and Netflix had significantly more storage space that allowed them to stock millions of niche items. Before the internet, a business lived and died by the local market. If you opened a bookstore in a small town, you couldn't afford to stock a book on 18th century French architecture because only one person in that town might be interested in buying it. That isn't enough demand to pay the rent for that shelf space. So you ended up only stocking the hits, like Stephen King's books, for example, because there is a higher demand for it. This is why we ended up with the hit-driven culture, where everyone watched the same movies and reads the same books because that was all that was available. The internet came and destroyed geography. This is where the economics get interesting. If we plot sales against popularity, we get a curve that looks like a steep drop, followed by a long tapered line. The head is where the top 1,000 hit sales are. Competition here is fierce. Every store has them, so you have to lower prices to compete, which kills your profit margins. The tail is the sale for the niche items. These are the millions of items that aren't popular, like a documentary on 1920s architecture or a specific cable for a 2005 printer. By itself, these sell very little. But when you add them all together, the volume of the tail equals or exceeds the volume of the head. This proved that people didn't only want hits. They bought hits because that was all they were offered. This unlocked a massive, previously invisible market of misses that was actually worth more than the hits. Amazon and Netflix took note of this, and they took advantage of the niche. It is considered historic because it identified a fundamental shift in how money is made, and it explains exactly why Amazon and Netflix crushed their traditional competitors. They realized that customers can buy the hits anywhere. But when it comes to finding obscure niche items, customers didn't have a lot of options. They recognized the opportunity in these niche items that can offer higher margins. Because they are the only ones stocking the niche item, they don't have to offer discount. As a matter of fact, Amazon makes more profit on a rare book than a bestseller. Of course, that was only possible thanks to their centralized warehousing and digitalization capabilities. Once media went digital, shelf space became virtually free. Storing a video file on a server cost a fraction of a penny. Instead of 5,000 small stores, they built massive distribution centers in the middle of nowhere where land is cheap. One warehouse could hold millions of unique items and ship them anywhere. They didn't need to predict if one specific neighborhood wanted a niche book. They only needed to predict if someone in the whole country wanted it. Now, they didn't just guess that product recommendation would work. They actually treated it like a scientific experiment. Amazon proved it using a method called A/B testing or split testing. They implemented it on their website so that 50% of users see the standard homepage with just new release. They call this Control Group A. The other 50% of users see a new section like, because you bought a phone, you might like this phone case, for example. They call this Test Group B. They then measure the conversion rate, which measures how many people actually bought something. The result was that the Test Group B bought significantly more. Amazon eventually revealed that 35% of their total sales came from these recommendations. That is a massive chunk of revenue that simply wouldn't exist without that data. As mentioned earlier, the need for data analysis and sales prediction has existed for as long as commerce itself. However, the birth of the internet brought with it the ability for businesses to record and store user data at reasonable cost. This led to the data explosion. Data wasn't just a byproduct of doing business, but has become an asset, something that could generate new value. It's a goldmine for prediction. But here's the catch. This data doesn't just magically provide valuable insights on its own. It needs to be cleaned, formatted, and analyzed. Before data engineer was a specialized role, the work of data analysis and prediction still happened, but it was often messy, fragile, and decentralized. It was typically solved by patchworks of 3 different groups. First, you had the database administrator, or DBA. Their main job was simply keeping the database online and secure. But to move data around, they had to write stored procedures. These were complex chunks of code living directly inside the database. While functional, they put a massive load on the servers and were incredibly hard to debug. Second, you had the accidental software engineer. They were backend developers whose actual job was building the main application. But they often got pulled into writing cron jobs, which are simple scheduled scripts used to export data to text files every night. These scripts were notoriously fragile. If the data format changed even slightly, the script would break, and no one would know until the next morning. And finally, the business analysts. They were responsible for the actual sales figures. Prior to data engineering, they had to manually export data from 3 different systems into CSV files, open them in Excel, and manually merge them using the dreaded VLOOKUP function. It was slow, prone to human error, and completely unrepeatable. Eventually, it became clear that this patchwork approach wasn't scalable. And that was when data engineering came into the picture. Data engineering is the branch of software engineering responsible for designing, building, and maintaining the systems that allow raw data to be collected, stored, and analyzed. It's important to distinguish the roles between data scientists and data engineers. While data scientists focus on interpreting data to find insights, data engineers focus on the how to ensure data is accessible, reliable, and in the correct format for those downstream users. During the extraction phase, raw data is extracted from various sources like databases, APIs, or logs. During the processing phase, the extracted data is then cleaned, transformed, and restructured to ensure quality and consistency. And finally, the processed data is then loaded into a storage system like a data warehouse, which is optimized for retrieval and analytical query. So we know the what and the who, but that leaves us with the biggest question of all for our next video. What really takes place when a data engineer designs, builds, and maintains these systems? The how. I'll see you in the next video.